the next concept is sign convention. To do the problems means we need to find out what is the focal length of the given mirror. For that, we need to follow certain rules. So these rules, which is given by Cartesian, so they are known as Cartesian sign convention. What it is exact means? So it tells about how we measure the distance, because if we keep object in front of the mirror, so we need to measure the object distance, and mirror itself is having the focal length and image will be formed somewhere, so that is also we need to measure. So to measure those, we need to follow certain convention. Convention means certain particular rules, so which is given by Cartesian sign conventions. I will explain these rules very easily, simply. Before that, I would like to recall your knowledge, what you are already knowing about this. You already knew it, but you do not know that it is that is. To explain much more about Cartesian sign convention, I would like to recall your knowledge by drawing a graph, which you already know how to draw a two-dimensional graph. So if you try to draw a two-dimensional graph, draw a two-dimensional graph. So this is the two-dimensional graph, which you already know how to draw it. And just name them as the knowledge what we are having it here. So this we will take as positive x-axis. That we will take as positive x-axis. So we will represent that as positive x-axis, positive x-axis, and this we will represent as negative x-axis, and here positive y-axis, and here negative y-axis, and this point we will take as origin 0, and right to the origins, these all are the positive numbers, 1 2 3 4 and so on and so forth. And to the left side, so this we will take as -1 and -2 and -3 and -4 and -5 and so on. Similarly, on the top we will take as 1 positive values, 2 3 4 5, and the down to that we will take as negative values, -1 -2 -3 -4 and -5 and so on. So this method or this technique only given by Cartesian, so that's why with his name we can call it as Cartesian sign convention. Suppose how we use this one, we will use the same Cartesian sign conventions in our mirror cases. That is, we will place the mirror at origin. So if you draw a mirror at here, so let me draw a mirror for a moment. So the pole should be at origin. So this is, for instance, just you take as concave mirror. Draw a concave mirror with respect to pole at origin. Now the first rule, The first rule is that object is always, that is the first rule, the object is always placed on the left of the mirror. So this is the first rule. It means we have to keep object always in the negative x-axis. Object is always on negative x-axis. On negative x-axis, always on left of the mirror. So that is the first rule. We always should keep object always on the left side of the mirror, or simply remember, object always should keep on the negative x-axis side. So we cannot keep object on the positive x-axis because it's a Cartesian sign convention. And second rule, all distances parallel to the principal axis are measured from the pole of the mirror. So this rule is very important. Suppose if we keep object according to the rule at here, so let me take, so this is my object. I kept object on the left side x-axis, negative x-axis. Now I have to say, where is the object? I have to measure what is the distance from the object. So for that, the distances should always measured from the pole. All distances should measured from pole. Now suppose if this is the object, I need to measure its distance from pole. So from pole if you measure, so the distance from pole is how much? If you can take 1 inch square as 1 centimeter, so the distance of the object from there to at here is 5 centimeter. Example, object distance. We will represent with a small u. So in this case, the object distance we are measuring from the pole. So now it is a negative x-axis. If we take 1 inch square as 1 centimeter, so now the object is placed at minus 5 centimeter. This minus sign is very important. So that it is known as Cartesian sign convention. It is only because of Cartesian sign convention. Okay. Now I hope these two rules are clear. The first rule, always you should keep object on negative x-axis or left side of the mirror. And second rule, all distances, it means object distance or image distance, any distance you can measure from the pole. Now for the same case, suppose if image form on the other side, suppose if this is the object, if this is the object, if in case an image forms at here, suppose if I take, it is a concave mirror. If the image forms at here, so concave mirror forms inverted image. So if the inverted image forms at here, Now we need to measure the image distance. Now same rule, we have to measure the image distance from the pole. So now the image distance from the pole means from the 0 to at here, you can take image distance up to there as we are representing as V. Image distance V. Now image distance equal to V equal to, in this case, minus 2 centimeter. Okay, suppose if it is a convex mirror forms virtual image. If image forms at here, if image forms at there, so then we can say the image distance in this case from here to there. Now the image distance V equal to here plus 3 centimeter. Now I hope you understand why we are taking the negative sign and why we are taking the positive signs. It is only due to because of this Cartesian sign convention. So these two rules are the very important. The first rule, object always should keep on the left side of the mirror or negative x-axis. The second rule, all distance should measure from pole. And we are representing object distance as U and image distance as V. Depends upon the nature of the image, so the image location gets changes. Now see the third rule. All distance measured on the right of the origin along positive x-axis are taken as positive. It means if you are measuring distances along the positive x-axis, you should take all those values are positive because it's a positive x-axis, that's why. And second one, and those measured to the left of the origin along negative x-axis are taken as negative. It means if you are measuring the distance along the negative x-axis, at here we measured object distance U as -5. So here we need to take them as negative. So that is due to because of sign convention. Okay, I hope you understand this point. Now for the third point. Now point number 3, third rule number 3. The third rule gives sometimes we need to measure the height of the object. Sometimes we need to measure the height of the object. Let me take my space. Suppose in this case, I want to measure the object height. Here you can see the object height at here is exactly, if you can draw a line from it here, it is touching exactly 1 centimeter. Now I can say height of the object. Now what is the height of the object? The height of the object at here goes to 1 centimeter. Now here how did I measure? It's due to because the one is on the positive y-axis. Now that becomes the next rule, fourth rule. Distances measured perpendicular to and above the principal axis along positive y-axis are taken positive. Suppose you are measuring these distances from origin to above along the positive y-axis. Now in this case, the values you should take as positive. Now in this example, I can write height of the object height of the object, we will represent it as h equal to, in this case, 1 centimeter. So here precisely it's a positive value. So the signs are very important, plus and the minus. Now suppose if the image form, in this case, if this is the object, let us take its form as inverted image at here, enlarged inverted image at here. So this is the image. In this example, now we measured easily the height of the object. Now I would like to measure the height of the image. For that, I need to take, where is the height? The height is up to, from there to at here. Now this image height is parallel to negative y-axis. Now what you can write the image height? Image height we represent as h dash equal to, in this case you can measure exactly at here, it is touching minus 2 centimeter. Minus 2 centimeters. Can you notice the positive plus and the minus at here? Yeah, it's due to because of the sign convention. So these are the rules we need to follow to solve the problems. So that will becomes as a fifth rule. All distances measured perpendicular to below the principal axis. It means negative y-axis are taken as negative. So these 5 are the very simple rules which we already know. This coordinate system, which is known as x and y coordinate system, which is developed by Cartesian. So that's why this is known as Cartesian sign conventions. So NCERT is given one nice diagram which makes us better understanding. So at here, this is the first rule. Object should always keep on the left side of the mirror. So this is the first rule. Okay. Now the second rule. If we are measuring, we have to measure all distances from pole. Distances should measure from pole. Now if we take towards to left, distances towards to left should take as negative, and distances towards to right to take as positive. Simplest rule. Why we are taking the positive and negative? Because this is positive x-axis and this is negative x-axis. That becomes the third rule. And fourth rule, if you take at here, along at here as a y-axis, if you can draw at here perpendicularly as one line, imaginary line, which I can call positive y and the negative y. Now see the third rule at here. The third rule says, let me clear, then we can see clearly these things. Now the third rule, height upwards should be take positive. Now AB is the height of the object. We will measure height along the y-axis. So this value we will take as positive, because it is a positive y-axis. And height downwards means if you get inverted image, we have to measure downwards. Now this height we will measure as negative y-axis. So with the help of this Cartesian sign convention, we can simply measure object distance representing as u and image distance representing as v, and height of the object as h and height of the image as h dash. So these distances we will measure with the help of the Cartesian sign convention.